Every view in SwiftUI must be uniquely identifiable, which means SwiftUI needs to know exactly which view is where and when at all times. This means all views have identity, something about the view that makes it unique. It comes in two forms. We have explicit identity, where we tell SwiftUI the identity for a particular view outright. This is what it is. And second, we have structural identity, where SwiftUI implicitly calculates identity for our view based on where they're used in our code. Regardless, all views must have an identity. SwiftUI will provide one where possible, but there are two places you want to do one explicitly. Very commonly, one we have dynamic data, like looping over an array, for example, and one we want to refer to a particular view, for example, scrolling to an exact location. Now, understanding why identity matters is so important. It really boils down to just the single biggest misunderstanding about SwiftUI. When you make a change in your view hierarchy, SwiftUI performs tree diffing to figure out what actually changed. And this would mean looking at the state of your view before the change, and again after the change, then walking through each to figure out what has been added or removed. Now, previously I said that when learners think about the parent of a view, they think whatever directly contains it. So for a text, it might be a VStack, for example. And that's okay while you're learning. This, I think, is a very similar situation. Tree diffing feels natural when you're learning and you imagine exactly how it works at runtime, walking through the tree. So I think it's perfectly fine as an answer when you're learning. For the first 6 months or a year of SwiftUI, go for it. Tree diffing makes absolute sense. I wouldn't correct it. However, the more experience you get, you realize in practice, tree diffing never actually happens thanks to the concept of identity. As it builds your view code, the Swift compiler has complete oversight into every subview you are using, with every modifier, every condition, every loop, and more baked into it. And these all get encoded right into the type of your views. We saw earlier with the type of self.body we called to examine the actual type of our view body, but it's really important you understand this extends to logic as well. For example, we could say there's a VStack, and here we'll do if bool.random, so randomly true or false, text hello. Else, text goodbye. And then I attach to the VStack on tap gesture, print type of self.body. Go ahead and run the code. You'll see you get hello or goodbye randomly. When I press on the text, you're going to see all sorts coming out here. Our same modified content, our same VStack as before, and that matters. As our modified content here because we have the tap gesture around it. But inside the VStack is a conditional content view, underscored here. So inside that has two text views inside. That's what's important. Now, when we look at this thing here, the conditional content, which is underscore, is considered to be a private implementation detail rather than something you want to try and manipulate directly. That's literally our if statement encoded into Swift's type system. That's happening right here. So the underscore means it's not exposed as public API. You don't want to work with it directly, but you can still look for it. You can still press Shift Command O and then look for build either like this here. You'll find a whole bunch of options, and here, boom, is conditional content underscored like that. And you can see it handles all sorts of options here for toolbar content or whatever you want to. There's a whole bunch of options. If I look for the one for views, here we go. That's command builder. Crikey, there's so many. Table row builder, table content builder, view builder. There we go. So we have true and false content here, and it returns one thing for true and one thing for false. And when our condition changes, which right now will be literally whenever the bodies are reinvoked, it's Boolean randomly, right? It hasn't got to do any tree diffing. It just flips from the true to the false content because it's just changed the Boolean. Now, it even does the same thing when handling switch statements. It collapses the whole switch down to a binary tree of possible states. If we had like an enum of view state with case A, B, C, D, E, and F, 6 different possible cases here. I'll say we have at state private var load state equals view state dot A. Inside our code here, we can now say which of these states we want to use. Now I'll use a at builder property called state, which returns some kind of view, and we'll switch on load state inside here. And if it's A, we'll do text A. If it's B, I'll say an image with the system name of plus. If it's C, I'll do a circle. If it's D, I'll say I want a rectangle. If it's E, I'll do a capsule. And then F, I'll do a rounded rectangle with a corner radius of 25, whatever. And now in our body, I'm going to say there's a button saying press me. And it will just do print type of self.data again. Sorry, state even. State. This thing here. Like that. Now I've wrapped this switch up into a separate property here so to make the type, the results of this easier to read. I'm not trying to read the whole body. It's a button of junk. Just read this bit here we care about. But give it a try. Press Command R and then see what comes back. So I'll press me. Boom. A whole bunch of conditional content. So in the very, very center here, we have it's either a text or image. And if it's that, is wrapped in another one, which is either it's this text or image, or it's this circle and rectangle. And that's wrapped in another one saying, well, it's either that thing or it's this thing. So it has to jump through like, true, for example, to get text. That would be the first value, this one here, and then the second value here, and then you get the text, for example. Or, true, false to get image or whatever. It has to jump through the little binary tree to figure out what to actually show on the screen. And this behavior of converting logic into types in our code has two important side effects, both of which directly affect how we use SwiftUI. First up, importantly, SwiftUI needs to be able, statically at compile time, represent complex view layouts, like a stack with 3 views and an image and a nested stack with a button, whatever you want to do. And secondly, that complex view layout is the actual underlying type of our view body. And remember, using modifiers transforms our views into nested modified content, views again and again and again. And using things like VStack causes SwiftUI to group views together into a tuple view. All these transformations create extremely long types for our views, which is where Swift's opaque return types, some kind of view, come in. When we write some view here as a return type for our view body, it means we don't want to explicitly spell out conditional content, text, image, We don't want to do that. We want to say it'll be some type that conforms to the view protocol, but we don't want to hide that information from Swift. It's less to know what's going back. We aren't trying to send back a protocol. This is actually an opaque type. Remember, SwiftUI needs to know our view hierarchy in order to update our layouts efficiently. But if we try to send back a regular protocol, if we're able to, which we aren't, if we're able to send back just view here, right? Then what we're saying is some kind of view will go back. But I don't want Swift to know what it is either. I want to hide that from the Swift compiler. And elsewhere in our code, that's exactly what you might want. You might say, I want to have some flexibility to the future. I might change from A to B, whatever you want to, double to int or who knows what. Some kind of numeric thing goes back. With SwiftUI, it's a very bad idea. It wants to identify all our views based on their type and position in the view hierarchy. So we have to say some view. Hide it from me. I don't want to tell you what it is exactly, but don't hide it from Swift. This is all made possible in the view protocol here because of a single line of code, which is down here, this thing. At ViewBuilder, at main actor, var body, self body, right? That explicitly marks our body property of our views using at ViewBuilder. This is a result builder that converts our layout into a carefully curated collection of tuple views and modified content and conditional content and more. I used it explicitly in our code here because it's required, right? We've got to say it here because that is not the body property. That gets that applied by a protocol. Body you saw has this thing attached to it, boom. But other properties won't. So I've got to say explicitly this thing is a view builder as well. Add it by hand. So we have modified content being generic over some kind of view and some kind of modifier. And tuple view is generic over all the views it contains. And so all that SwiftUI eventually ends up as a complete overview of our layout. It can literally guarantee the contents of a VStack, for example, even when using it with conditions and loops to assemble it, which in turn means all the views have a clear structural identity. It knows where they all are. This text is inside conditional content, inside this conditional content, this conditional content. It knows exactly where it is. Now, maybe you're wondering why this all matters. And the answer is that the identity of our view dictates its lifetime, how long it lives for. And as soon as the identity of a view changes, either structurally or implicitly, the view is destroyed. Now, from a performance perspective, this is pretty bad, because SwiftUI will throw away what we call the platform views, the underlying UI view or NS view or whatever used to render your SwiftUI thing on the screen whenever they're matching SwiftUI lifetime's end. Toss them away. But it'll also destroy any data your views were storing, because as far as SwiftUI is concerned, you asked your view to be destroyed. Now, you already saw how conditional content is generic over its true and false content types. So perhaps you can see this is leading. When we flip between two views using an if condition, it causes SwiftUI to throw away its platform views and all the state we created every time. We can see this in action with some more code. We can say, there's a new struct called example view, which is a view, has an @state private var counter of 0. And there's a body property inside here. Oops, body property. There we go. With a button, I'll do tap count is counter. And when it's pressed, counter plus equals 1. And then I'll say @state private var scale up equals false. And then in our body, here, just here, I'm going to say there is a VStack with a capital S. If we're in scale up mode, then example view with scale effect of 2. Otherwise, a regular example view. And after that, we'll do a toggle saying scale up is on of $scaleup.animation, like that. Oops, daisy. And add a little bit of padding around the VStack, like that. Okay, see how that looks. So we have our text tap count here. I can press this thing to go up to various numbers and so forth. And I can toggle the scale up button to be on or off. But notice how it's moving in a really strange way. So we've got this thing saying either be double your size or regular size. What actually happens here is pretty ugly. You'll see it happens as a fade. It sort of fades in and out like that. The smaller text fades in, the other one fades out, button, like that. And that's fine, but it's not ideal. Then the tap count resets every time. Goes away. Back to 0 every time I'll toggle the switch. Both of these happen because of that conditional content flip happening. SwiftUI destroys the original example view when this stops being true. And it'll go to the other example view and create a different one. And so the fade effect happens because we're seeing a transition, destroying one view and bring a different view in here. And it's not animation, it's a transition instead. And as for the state being lost, this thing here is being set to 0 every time. This again happens with SwiftUI because it considers the original view to be different. It's destroyed, and so it removes all data at the same time. So we're losing data, we're losing animations, and making SwiftUI do a lot of extra work here because having to recreate all those platform views as we're changing. There's two different views here. This problem remains even if we remove the view modifier. So all we're doing was changing the way example view is being created. If I had said something like, let's make scale be passed in here as a double, and then apply the scale effect here, scale. And now I'll say if we're scaling up, do example view as scale of 2, otherwise up view scale 1, it'll still have exactly the same problem. Let's play it back. Up, it'll say it fades, destroys the state. It's pretty ugly, right? We don't want that at all. Where things get interesting is when we try to add some explicit identity. If I had said, actually, these two views, they're really the same view, I'm going to say that by adding an ID to them both of example. They now have an explicit identity of example telling SwiftUI they are the same view, right? And you might think that's going to work. because now it's saying SwiftUI, actually they're both called example, the same thing. These are two of the same instances here. We'll still get the destruction of state and the transition. It has not worked here at all. The problem is that, well, it probably isn't that having two example views is bad, right? This is actually fine. You can do this just fine. And SwiftUI can often figure it out, especially with this ID modifier here, right? The problem is this conditional content is being made. It is designed, as you saw earlier, to be generic over two different kinds of data. By design, it has two different views. That's what I understand. I've got one view, different view. They are different views. No matter how we ID them, they are the same view here. It is hard coded to think of these views as being different, being distinct. And so whatever modifiers we attach to them doesn't matter. They are distinct as far as SwiftUI is concerned. This means from a structural perspective, our two views are different, no matter what explicit entity we attach to them. And remember, this type here, conditional content, exists because the View Builder protocol explicitly marks its body property of a view as being View Builder. That's what it's doing. It says view has a body that's a View Builder by design. And when we get our code out of body, we don't get that View Builder transformation happening unless we specifically ask for it, which means you don't get conditional content being used. And that means in turn, SwiftUI can rely on the explicit entity we passed in. We can see this for ourselves. If we move our code out, we set something like var example view is some kind of view, and then paste this code into there. Let's take it up into here, and then say return that and return this. So now putting our code directly into a different property, and I'll replace that down here in the VStack with just example view, show that property here, I'll press play, and it's very similar now, but SwiftUI will now work as expected. We get a nice scaling animation, we're going up and down smoothly, we increase tap count to 7 and go up, it's still 7, 12, go down, it's still 12. SwiftUI now works as expected. We're preserving the state between both views, we're animating correctly, and performing more efficiently. The buttons aren't being destroyed and remade every time here. Even better, we can actually remove the explicit identity. It will still figure out it's the same view correctly and animate it nicely. It understands. As usual, I'm going to explain why in a moment. But first, I want you to think about it before you listen to my answer, okay? Just pause the video. How can SwiftUI understand these two example views are the same, even without an explicit ID attached, when it couldn't do it before? Pause the video, have a little think. I can wait. Okay. The answer is that by removing the @ViewBuilder transformation, we're also removing all this conditional content happening here, which means flipping between the two view states no longer means moving between a true and false view. Instead, because the example view property is used in a fixed position in our layout down here, SwiftUI can rely on good old structural identity to realize the two example views should both map to the same underlying view. The property might return example view scale 2 or example view scale 1, doesn't matter. Either way, it's an instance of an example view, so SwiftUI considers them the same. And this might sound ridiculous or might sound dangerous. Our code specifies two different example views, so why should SwiftUI consider them to be the same? Understanding this gets to the very heart of what @state does and why it even exists. You see, when SwiftUI evaluates a view's body property, it will create a new instance of all the view structs inside. It'll call a new VStack, new example view, new toggle, padding, and so forth. It has to. Structs always have a unique owner. It can't somehow reuse the struct from a previous body invocation, and so even a trivial view will be recreated often, which means SwiftUI regularly has to map the old struct to the new struct. To recognize that two instances of a view struct are the same and should share their data, and this is why we have state. It has to understand they are the same, should share the same state, it can preserve that state correctly over time, and when our example view property here returns the same view type without using the view builder transformation, it's really no different from having no condition at all and returning a single view. Doesn't matter SwiftUI. Maybe a struct, got an underlying view. Doesn't matter how you make it, same underlying view is mapped to it. Now, of course, by ditching the @ViewBuilder transformation, we've lost all the things that make SwiftUI special, right? We've got to return exactly one specific kind of view here from both our conditional cases. So we are now out of luck if one case wants to add a background color while the other one doesn't. Now, what SwiftUI really wants, and the kind of code we want to aim for across the board, is to use the ternary conditional operator instead. In our content view, we'd have something like this. We'd say there's an example view here, and the scale will be if scale up is true, 2, otherwise 1. That's what it wants to see. That's its ideal code, and you'll see it animates correctly and stores state and yada, yada, yada. Now, using this approach, we're back to having structural identity do all the hard work for us. Regardless of the value of scale up here, we still have an example view as the first child of our VStack. So SwiftUI will keep it alive as the Boolean value changes. I think here, the problem is pretty clear in our current code, but it might take some more thought in more complex code, depending on which iOS version you're targeting. For example, you might have some code show a message in bold if the user hasn't read it yet. Something like this, private var is new message equals false. Then something like if is new message, then text, capital T, message title here, dot bold. Else, just text message title here. That. Now, how can we write that as a single view? In iOS 16 and later, they've made this bold modifier accept an isActive Boolean. We pass in just is new message here to reuse the view once, effectively like this, right? But the 15, 14, and 13, there's no option. You've got to either use bold or don't add bold. There's no option here to try and add a Boolean going in. So if you aren't able to target 16 or later, the fix here should remove bold entirely and replace it with a font weight modifier. Font weight like this is new message, then dot bold, otherwise dot regular. That is the code to use 15, 14, and 13. If you can go 16 or higher, you can just use bold with a Boolean attached. You actually got even simpler here because font weight actually takes an optional weight, meaning we say nil for the default weight, whatever should be the right weight for this particular situation. Now, some SwiftUI modifiers simply refuse to accept a customization parameter, with the most notorious being hidden. It unconditionally hides a view in our layout while leaving space for it where it was, and this means using it puts us back to the same state loss problem from earlier. If I just undo our code a little bit, here, where are we? Come back to the right way back. If should hide. Let's take this whole thing here. Let's put this all up in here. Boom. Okay, let's put it into there. We had roughly this earlier, like this. I changed it to be private var should hide is false, and if we're doing this, then if should hide, I'm going to say do example view with a scale of 1 but hidden. Otherwise, example view of state of 1. And then we'll just do down here. Let's do a button, in fact. It doesn't make sense as it was. Toggle with animation. Oops, daisy. Should hide dot toggle. Boom. And this is going to work better. You can, hide it or show it, and it's kind of where we were before. It's gone back to 0 every time, which obviously is bad, but it's kind of what we're stuck with because hidden does not take a Boolean parameter here. Remember, the problem here is with the view builder that's attached implicitly to our body property here. The problem isn't the example view. That can represent state just fine. Even if you try and build an improved hidden modifier that takes a Boolean, you'll still fall foul if you try and adopt the view builder. If you said something like extension view, let's say at view builder, func hidden takes a hidden boolean now, returns some view, if hidden, self.hidden, else self. And you might think that kind of works around it a little bit, but it's not, because you're the same problem. This view builder will turn this into be a conditional content of true and false. So you can't work around it, even by having an extra hidden option here. The key again is to use a conditional turning operator, which means no more need for view builders. So you'd say something like self.opacity is hidden, then 0, otherwise 1. And this will now preserve our view's identity regardless of the value of hidden. It'll make sure the same view is alive the entire time. So while it takes some extra work sometimes, using identity properly increases performance, preserves your state, and creates better animations too.